Hello, Lynchburg City students. I'm Tristan Brown, and I'm happy to be here again to bring you another SAT prep video, specifically math SAT prep. As you guys know by now, that is pretty much what I do. Today, I'm very thankful we're in the very last section, or the last section of the last topic is probably a better way to put it, but the last topical section of the math SAT. We're in the additional topic section, which of course entails a lot more than any of the other three sections. This has geometry problems and trigonometry problems. I found out we deal with some imaginary stuff in this section. So there's a wide array of problems that this section involves, but today we're going to focus on, well, I guess we're dealing with cosine. That's technically a trigonometry principle. However, most of what this problem involves is geometric principles, so we can get to that point. And most of the time, you'll see geometry and trigonometry are intertwined a lot into problems such as this. So that being said, today's problem is a hard problem. So again, if you struggle with this one, that's okay. It might take a little bit to get the notion of there's a lot involved with this problem. So don't feel bad if you need to go back and watch this video a couple times over to make sure you understand everything that's happening in the problem, so that when you get to the SAT yourself and you're not watching the video, you still have an idea of what to do. So just keep that in mind. That being said, let's get to the problem. So it gives us this triangle with this one side of 24 feet, these two congruent angles x, and this other side that is 32 feet long. And tells us that the figure is not drawn to scale, which I would like to think it was obvious that this is not 32 feet long. And it says, what is cosine of x? So the problem itself, it's 3 words. It does seem fairly simple from that perspective, but there's a lot from this picture to get to cosine of x that we need to do. So I think first and probably foremost, the thing we need to make sure you guys know is what cosine is. So cosine let's just put cosine first. It looks like my marker's a little big, but maybe not. Not gonna let me switch again. That's okay. No? Huh. It seemed a little big. Maybe that was what I've been using. I don't know. So we say the cosine, no, that's definitely what I use. Cosine is equivalent to the adjacent side, which I'm going to abbreviate to ADG, over the hypotenuse. I don't know if your teachers have told you this outright, or hopefully you've been able to infer it. If not, a hypotenuse only exists on right triangles. You'll never be asked to find the hypotenuse of an equilateral triangle or of any non-right triangle, because it's just irrelevant. Again, the hypotenuse of a right triangle is just the longest side, the side opposite of the right angle. So that's, in theory, a hypotenuse, any triangle that's not equilateral has the longest side. But the specific terminology of hypotenuse is only used for a right triangle. And for where we're at, where you guys are at, you can't use the 3 trigonometric functions on any non-right triangle. You have to get into calculus, and there's the law of cosines and the law of sines, so you can do that. But at the point we're at, it involves calculus that you guys, I would say for the most part, have not been introduced to. So we have to figure out how out of this triangle we're going to get a right triangle, and this is where the geometry comes into play. We know that these 2 angles are congruent. So what that means, hopefully you guys remember, any triangle that has 2 congruent angles, or has exactly 2 congruent angles, is an isosceles triangle. And we have a principle that in an isosceles triangle, from the vertex opposite of the 2 congruent angles, or I guess the vertex that's not one of the 2 congruent angles, we can draw a perpendicular bisector from that will evenly split this side between the 2 congruent angles. And since it's perpendicular, that means it meets at a right angle. And since it's a bisector, it means that both of these lengths now are both going to be equal at 16 feet. All I did was divide 32 by 2 to get that, just in case you were wondering. So now that we have that, and you could, it's also, since this is isosceles, it means this side's 24, so this side is also 24. So you could use either side. However, since this one's already labeled, I'm just going to use this side for reference. And it tells us to find cosine of this angle x, which is going to be equal to the same angle x. And where you want us to find the cosine of it, cosine is just the adjacent side. Adjacent is the side that touches this angle. And again, the hypotenuse is the longest side, or the side opposite of the right angle. And again, if you weren't sure, you could use Pythagorean theorem to find out what this side's length is, but that wouldn't be overly helpful and would just take time away from the problem you actually have. So what I'm going to do, we have this side, we have the adjacent side, which is 16 feet. And remember, we are stopping now at this side is our opposite side now, and not this, since we've divided our triangle into two parts. However, that won't change the angle length here. We didn't do anything to it. So we have this adjacent side, and we have the hypotenuse. So this one is actually fairly simple. It's the cosine of x equals 16, the adjacent side, over 24, the hypotenuse. And that can be reduced. Both of those numbers are divisible by 4. Both of those numbers are divisible by 8. So therefore, that's equivalent to 2/3. 16 divided by 8 is 2. 24 divided by 8 is 3. So if I did everything right, that will be our answer. Let's see. If my screen loads, we'll see. It's gotten close. And it is, it's 2/3. And now it's gone a little too far, but that's all right. Wow, it's really doing something now. It's wild stuff, isn't it? However, now that we have this, the SAT could have asked you to go one step further and ask to find what x is instead of what the cosine of x is, in which case you would still need to find cosine. So I hope you guys know. If you don't, that's okay, though. That's why I'm here, I guess. So x, remember, that is our actual angle, and it would ask for either degrees or radians. It would tell you. And I'll show you how to find both here in just a second. But I hope you guys remember or are ready to learn if you've never been taught it. But to find the degrees given what a measurement, if we have cosine of x, we can find x from that. Or if you have any of the three trigonometric functions, you can find x or whatever your angle value is from that. And all you have to do is use the inverse trig function. So if we had this, what we're going to do is we're going to use the inverse cosine, or cosine to the -1. And when we do inverse, we flip these two. So we have negative cosine to the -1, the inverse cosine, or arc cosine, as you also hear called, and that equals x. And since this is a calculator section, they can't ask you to do this. If you give me 1 second, I will actually pull up my calculator I have on my computer, and that's equivalent to the calculator that you guys have, or that you will have on the SAT, which is hopefully the TI-84. I have the emulators, the silver edition. I personally don't own an actual silver edition, so it's more bland, but they do the exact same thing overall. So what we're going to do, we hit the second button, and it gives us access to anything on these buttons. Over the buttons, you can see there's all these words in blue, and when we hit the second button, it gives us access to all of those, everything in blue. When we hit the button, so if you look, this is cosine. If you look right above it, in blue, it has cosine to the -1, which is what we want. So if I graph that, or if I hit that, it gives us this cosine to the -1. And then we want it of 2/3. However, I don't know if my calculator is in degrees and radians. I can't remember what I had it in last. It's in radians. More than likely, your SAT would ask for degrees. It's not necessarily, but more than likely. But to switch, all we do is we come down, and we're selected on radians. The one that's highlighted is the one that we're using. And I just come over to degrees. I hit enter. Now my calculator's in degrees, so then we hit second, quit. That'll get you between any screens that aren't your just main calculation screen, so that's incredibly important. So make sure you know that. So now when I hit enter, it's going to give me an output in degrees. So I hit enter, and it gives us this number. It would probably ask you to round off to the tenths or the hundredths, or maybe just to the nearest degree. So given that, if the SAT did ask you to go that extra step, x would equal, well, let me put approximately because I'm not writing out the whole decimal, is approximately 48 degrees. So that I just wanted to make sure, in case on your problem in the SAT they ask you to find the actual measurement of the angle, that you guys knew how to do that. Thus far, I haven't found a problem or recorded a video for a problem where that is the case. So I want to make sure I just covered that in the event that you would have that sort of problem. So why was that the solution overall? Like I said, since this was an isosceles, we had to draw a perpendicular bisector from this vertex, the unlabeled angle. From geometry, this segment, since it's a bisector, evenly splits this. So the 32 feet was split into the two equal pieces, which were both 16. Cosine, of course, this is probably the most important thing to take away from this video if you didn't know it. Cosine is adjacent over hypotenuse. Just for reference, in case we don't get to it in any other videos, sine is the opposite side divided by the hypotenuse, and tangent is the opposite side divided by the adjacent side. So make sure you know that 100% without a shadow of a doubt going into the SAT. That's going to be very important to know. So make sure you do know that. And then from there, we just plugged everything in to get down to 2/3. Like I wanted to mention, that there were a lot of theorems and postulates from geometry that you need for this question, and a lot of other problems in this section you're also going to need, not necessarily the same theorems and postulates, but you're going to need other ones from geometry. Now I want to specify, you get a lot of problems with triangles. You get problems dealing with parallel lines, and then probably not as much as those two, but you do get some problems with circles. And that's pretty much what entails this section on the calculator section. You'll see once we get into some of the non-calculator problems, that's more where the imaginary numbers come into play, and you'll see them on that section a lot more. I haven't found a problem in the calculator section that uses imaginary numbers, so just keep that in mind. It's obviously possible. They are allowed to give you problems like that, but I haven't found one thus far. So take it for what it is. And then my tip for today, again, prior to calculus, you can't use the trig functions on anything other than right triangles. And even in calculus, there's a specific law, that's this long equation that you have to use to do so. So at this point, you guys can't do that. So in any problem like this where it gives you a non-right triangle, you have to figure out a way to get a right triangle out of it so that you can find that trigonometric function. So that's all I've got for you guys today. I hope this video was helpful. Thank you guys so much for watching, and I will see you at the next video.